So, hello and welcome to the first lecture called Mathematics of Porsche. And in this lecture we are going to study the aerodynamics of rear spoiler. So basically the mathematical background of how the rear spoiler of a GT3 Porsche RS that you actually saw in the introduction works. So basically we have here the Porsche, and the air is coming from the front part of the vehicle, and you see that in order to reduce the drag produced by the air, the designer of Porsche, they tried to give the car its very typical racing sports car shape, which is a little bit like a shape of a wing of an aircraft. And you know from aircrafts that the wing, their purpose is actually to produce uplift. So when the aircraft is on the runway, basically it accelerates, and when the velocity of the aircraft is high enough, the wings of the aircraft, they produce enough uplift to make the aircraft take off. And so basically this is something that you have here as well, because you try to reduce the surface, that's the attack surface of the car, and then you get the typical shape of this particular Porsche design. You see here the rear spoiler of the car, and we are going to study this in more details soon. And basically, due to the fact that I described, the uplift of the shape of the car, you have some minor force, uplift force going up. And of course, you have the mass, due to the mass of the car, you have the down force, which is the gravitational down force, which is basically located at the center of gravity or center of mass of the car. So that's here the picture of the Porsche car when the car is on a curved, on a banded trajectory, and so basically it takes a bend, and then there is an additional force that comes into play here, which is called the centrifugal force. And the centrifugal force is the force that you actually also experience in a car when you drive in your car. It's the force that tries to push you out of the car when you go into the bend. So basically you have the centrifugal force here, and then you have the additional force that is created by the rear spoiler, and that's actually the purpose of the rear spoiler, is to produce this very large force that pushes the car down, and it helps to keep the car on track. So to keep the Porsche on track and to equalize in some sense this centrifugal force, because when you equalize maximally the centrifugal force, then you basically can go into curved trajectories with a higher speed, and that's what you want to do with the racing car. You want to be very fast, so you want to go into curves, into bends as fast as you can. So this is basically the introduction. What we are going to do now is to summarize all the ideas in this drawing here. So you basically have like a sketch of this picture here. So you have the down force due to the mass of the car here. Then you have this up force, this uplift force due to the shape and design of the car. And then you have this additional force of the spoiler, of the rear spoiler. And we're going to put arrows here because we are talking of vectors in mathematical notation. And so what we didn't put yet on the sketch here is the centrifugal force. But we are going first to discuss this particular force here, Fs. So the force of the spoiler. And I sketched, in order to do this, I sketched here a drawing of a spoiler. And basically, so that's where the spoiler is fixed here. So this is this here. So this is when you look at it from the side. And you basically have the air going like this. And then you have the airflow going over the spoiler and under the spoiler. And what you can actually see intuitively is that the length of this part here, so going from here to here, we call it T1, that's the length of the part. It's actually smaller than the one going from here to here, which we will call T2. So what we have is that T2 is larger than T1. And basically the air is coming, when the car accelerates, the air is coming from this side here, and it goes over the rear spoiler, so it goes like here, some part of it goes like here, and the other part goes like here, and takes the longer trajectory. So a law of physics says that there cannot be like annihilation of particles, so the particle that enters here on the spoiler has to be as fast going this trajectory as fast as going this way. So basically the particle here, as it has to go over a longer segment here, it has to be faster. So what we have is that for the particle here, the velocity v2 is larger than the velocity v1. And then we make use of what is called Boses Law. And basically Boses Law tells us that it's actually an equation between pressures and velocities of masses of air flows. And basically you have like P1, which is the pressure here, experienced here, so P1. And you have plus the velocity V2 to the power squared divided by some factor or multiplied by the density of the air and divided by 2. And then you say it's an equality between, V1, and then it's an equality between the pressure under the rear spoiler, so P2, plus the density of the air, which is the same because we are in the same fluid, and then you have the velocity V2, which is this time the velocity here, so it's V2 is here, and V1 is here, and V2 is here, and you divide it again by 2. So that's basically the equation. So let's write this here in a more proper way. So basically here you have V1. That's important. So we basically saw that V2 is larger than V1. And so the square of V2 is also larger than the square of V1. This is the same in both factors, and 2 is the same, of course, of both sides. So what we see is that this quantity that we will call Q2 is larger than this quantity that we will call Q1. And if this quantity, so basically we have Q2 is larger than Q1. And if this quantity is larger than this quantity, then to keep the equality, we need this quantity to be smaller than this quantity. So basically from here, what we obtain is that P2 must be smaller than P1. So the pressure under the rear spoiler is smaller than the pressure over the rear spoiler. And that actually creates an effect of downforce, because the pressure from this side is stronger than the pressure on this side. So basically the P2 is this and P1 is this. So the sum of these two forces make a net force that goes down and pushes the car down, like I draw it here in this particular picture. So basically that's the explanation of this force here. And to make the relation between pressures and forces, basically pressure is nothing else than a force divided by a surface. So basically you have a surface, and then there is the force acting on the surface. And that's what is called the pressure. So basically pressure and force and the magnitude of the force, they are proportional one to each other. So then we come to the last point here, which was the centrifugal force when the car is on a banded trajectory. So basically what we have here is we have a centrifugal force that goes from the center of mass out here, and we call it Fc for centrifugal, and this force is proportional to the square of the velocity of the car, so the velocity of the car divided by r, and r is actually the radius of the banded trajectory. But this is not so important for the moment. But what you see is that it is directly proportional to the velocity of the car. That is important to keep in mind. So basically, what do we have here when we create this downforce, force of a spoiler? So basically, what we have is that at the level of the tires, there is some additional force pushing the car down and creating some additional rubbing, so some additional friction. And this additional friction, again, creates some force going in the other direction, in the other direction of the centrifugal force. So basically you have smaller forces, you have an increase of these forces going on the other side, so from the center of the wheels. So you basically, with these additional friction force or rubbing force, let's call them rubbing force, let's call this 1, and this 2 for the second tire here, you basically are going to compensate this centrifugal force. So now with this here, basically you understand that the additional force created by the rear spoiler of a Porsche actually helps to be faster and to take trajectories that banded trajectories faster than without a rear spoiler. So I hope this helped to understand a little bit the purpose of the rear spoiler. If you have questions, please leave a message in the comment section below, like my video, and see you in the next video.